Hi, I'm Frank Hitzel from Double Fox. I would like to introduce the new image optimization module for the CorrMeas microscopy automation software, which is now available for all Zeiss scanning electron microscopes. When you perform automatic imaging with microscopes, the whole process should ideally be running without any user interaction. At the same time, the image quality should be as good as possible. For scanning electron microscopes, this means a longer process needs to care about focus and stigmata changes and control these settings from time to time to keep a good image quality. For an automatic process, autofocus and autostigma routines must be fast, reliable, and controllable by software, as no user is there to check the outcome of an autofocus or autostigma process. The standard built-in interactive automatic functions are often not reliable enough to run without user interaction. Therefore, we have built a new, fast, reliable, and controllable automatic routine for this purpose. These routines rely on our own image evaluation technique, which makes the functions highly stable and universally applicable. While I talk, you see a demonstration on different sample times. The functions can also be activated manually. If the current photos is close to the optimum, a focus refine just takes a few seconds, as shown here. A single click and you get an optimized image. It gets a little more complicated if also the stigmator needs to be changed. A stigma in focus refine takes about 3 to 4 times longer than a pure focus refine, as 3 parameters need to be optimized. If the stigmator is very far away, as you can see here, the 3 parameters strongly influence each other. The result of a focusing operation is harder to evaluate if the stigmator is off, and the same for the stigmator if the focus is off. That makes it often complicated for beginners in scanning electron microscopy to find the optimal settings. As you can see here, the used algorithm works iterative. It means it first optimizes the focus, then stigma X, then stigma Y, and then focus again, and again stigma X and stigma Y, and so on until no more improvement can be seen. Now let's switch to the CorrMeas software. If you want to work with this module, you need to load it in here under the add-on dialog, and then happen two things. The first thing is that you in the view menu get a new menu point called Image Optimizer, and you can fetch a new dialog window which provides some manual callable functions. You have several buttons here to press. And on the other hand, if you go to the Automator window here, if we switch, for example, into visual mode, you see under functions a new group called image opt. And this more or less represents the same and a little bit more functionality than what you can see here in the dialog window. And of course, the advantage is that with this functionality, you can create your own workflows in which you can use the image optimization functions in an automated way. Okay, let's do some automation. So I have here the state system of CorrMeas. I have for stored position and a few imaging conditions. So one position is this here. It's a special point on the gold carbon surface, and we have this thing there, and then we have another position on the gold carbon surface, and when we zoom in, then we have this thing there, then a third position, the whole sample again with some point there, this one here, and then we have some position on the semiconductor sample, which is this corner here, and when we zoom in, we are directly on the corner. You can see the state system in this case is used to define both a position, an image size, and also have a reference image to perform an automatic beam shift correction so that we hit within, I would say, 100 nanometers the same spot. And when we do this, you can see that the images reach a certain quality. The state also saves the working distance at the stored position. So this is a optimal case where you can see what you can reach without doing any adjustment of the focus and stigmator when going to different positions on a sample. So what we want to do is we just want to make a small script which then automatically goes to these 4 positions and then takes an image in 90K magnification. We do this in the visual editor again. The nice thing is you can just drag and drop the states into a sequence. So what we want to do is we want to have the first one here like that. Then we want to switch to 90K resolution. And then we want to grab an image. And this is here in the CorrMeas function, table grab for position. We use a predefined, there are some predefined positions starting at 1 here, and I want to just use the first one, and this is actually index 0. Okay. Now this goes to the position, then switches to the high magnification conditions, and then grabs it. And we want to do this for all 4. We can then add some positions here, and I want to. Now, well, how should we do it? We can just put this here. That's the second one. Then we have the third one, and then we have the last one. And after that, we want to switch to the 90K stage. We can just copy this here. So we want to put it here. We want to put it there, and we want to put it there. So like this and like this. And the last thing is then to grab the image. This should be done after the 90K. So we want it here, we want it there, and we want it also here. Where do we have it here? This one goes here. We make it number 1. This one goes here. We make it not 12, 2. And then the last one goes here. We make it number 3. Okay, so let's run this. That's quite okay. In the text version, this also looks quite reasonable. Yeah, you can. It doesn't matter whether you edit it in text or in the visual way. So if we press run now, you should be able to see this like that. Now it moves to the first position. It captures that, and we have it stored up here. Let's first finish all of them. You can see it here in the corner already. It's the second position. Now we come to the third position. Now the last position. Okay, that's it. You can see the images now here, and if we look at that, we see this quality here is actually quite good. Maybe luck, maybe good stored position. This quality is also quite good, and this here is some, I would say, they're actually not so bad, I would say, but this is more or less good log how good it can resemble that. When you have a real type sample, then if it's a wafer, it's bent sometimes, and then the conditions are not as nice as with this very small samples. But what I want to show now is how does the image improve if we add after each acquisition or before each acquisition, we can add some focusing operation, and we do that by going here to the functions, not CorrMeas, but the image optimization. Let's start with, now we can make a focus refine. The images are already so good that we don't need to make a long search for focus. So we want to insert this here after switching to the imaging condition. So image opt focus, this is a refine. And going then here after the 90K, focusing, and here we have the 90K focusing, and then here we have it as well. Good. Then let's start that, and let's see how the images then compare to the other one. Now it's in operation again. You see the first image. Now it makes a focus operation. And then when this is finished, it captures the image. Then we take the second one. You can see we have a stage here with about 5 micrometer precision, or maybe optimum 3 micrometer precision. But we hit within, I would say, 50 nanometer, the same spot again. So this is, of course, because we use the cross-referencing by image correlation. Otherwise, you would never hit with this precision. Okay, it's the last image now. Like that. And now we can compare the quality. Here it's the first one. Here you can see a strong difference in image quality. So here the autofocus have done something. Here, here you can see maybe a little bit better, but not very much. It was already quite good. And at this one here, I can see the borders have become a little better. And then at the last one, a little bit improvement, I would say. Yeah. We are already at relatively high magnification, 90K. We now can see or try out what happens if we change the full focus uh, into a focus stigma. Maybe it gets even better then. Or should we go to full focus and stigma? Yeah, maybe we take the full focus and stigma just to get the optimum. Let's take this one here, this out, this in. Good. Next one, this out, this in, this out, this in, and this out, this in. Yo, that's it. Can delete the ones there. Okay, let's try again. Will take significantly longer now. Um, now it scans for the focus. That was the focusing stigmator. Stigmator has an effect. Let's see whether this can improve anything. Now stigma Y. Well, I think it did some improvement. Now focus again. That's the first image. Second position. Shifts a little bit out and there's not very much detail there. Hopefully it works. In an automated process, you commonly know where you have some features to focus on and so on. So you should make the program so that you always focus on something with some details. But I think this has worked quite well. And now the next one. Searching focus. Stigma. Another stigma. And done. Last position. Focus. Stigma X. Image gets brighter. Probably cleaning some surface coverage. Okay. Finish. Now let's compare. The first images are always at the beginning here. I will move this away. So we have, this is the last image. So this is, then we have this one, which is only with focus. You can see that the edge here is on that image even a little bit better. Yeah, so it has improved something here on that. On this one here as well, yeah, the new images has a little bit better corners here than on this one. Then we have that image. Now also here, you can see this looks a little bit more, yeah, has a better impression here. And here, okay, we have the we have a change of the surface by this this material seems to be more sensitive to the, but you can see that the overall quality is much better. You can see here the double line where you here only can see the first line. But anyway, in comparison, the step from the first one here, this one was even better than the second one with the focusing, but this is still the best. But depending on the time and how good this is needed, you can see a larger usage of time can improve or can yield to improved image quality with this. But you see the functions work reproducibly and can really improve the image quality for automatic imaging, even though you have so different conditions like we see here in this example. The image optimizer can be customized to different conditions via the setup dialog. When you open the setup dialog, you see different parameters, including the currently calculated sharpness for the current image. One thing to change here is, for example, the captured size. So commonly, you have seen in the videos, we use 128 square pixels, but you can also for use larger areas for the operation so that critical parts don't drift out so easily out of the frame. You can also use different scan speeds. Of course, a higher scan speed leads to a faster operation of the focusing operation, but also to higher noise, and it may not hit as efficiently. So you can see here that the last operation was not as successful. Yeah. Slower scan speed means lower noise and therefore a better result. You can also see here in the diagram, you can follow the activity. So if I go a little bit away from the optimum and press refine, you can see that it will hit not in the 0 position, but the new optimum will be out of the 0. 0 means the position where the focusing action has been started. Okay, we are on the end of this demonstration. Many thanks for your interest. If there are any further questions, please contact Double Fox or your Zeiss sales contact.